So in another video, I said I wouldn't do it the way the book did it. I would do it a different way, and I'd show you that. Okay, here's the other way, and it's to use triangles. So I really like using triangles, and I'll explain why as I go through it. So they give us some information, and then there are 4 parts to this problem. They want to do a sine, a cosine, and then a tangent with addition and a tangent with subtraction. Okay, so what I do is I look at the information they give me. They're telling me that the sine of alpha, so they're giving me the sine of alpha, and then they're telling me that alpha is between 0 and pi over 2. That means alpha is in the first quadrant. So what I'm going to do is I'm going to draw a triangle in the first quadrant. I don't know how big that triangle is, but I'm going to call it alpha. And then what that means is there's a right triangle right there. And you could think about that point that you have out here at the end of, whatever circle you want to have. But I'm going to do this in terms of adjacent, opposite, and hypotenuse. Okay, so this is my triangle for alpha. I know that it's 3 over 5, and that ratio is opposite over hypotenuse. So I'm going to make my 3 the opposite, and I'm going to make my 5 the hypotenuse. And then you can use the Pythagorean theorem to find the other side. In this case, it's going to be 4. I'll write out the Pythagorean theorem on the next one, but that's what you get if you do it. Okay, that tells me all 3 sides of the triangle. Then I know all my trig functions for that angle. So I know the sine of alpha. They actually told me the sine of alpha, 3 over 5. I know the cosine of alpha, which is 4 over 5. And I know the tangent of alpha, which is going to be 3 over 4. Now, all of them are positive because it's in the first quadrant, okay? So then I'll use this little chart I have here for alpha. So whenever I need a trig function, I'm going to just go there. Now, I'm not going to need cosecant, secant, or cotangent this time, but I could find those if I needed to. Okay, so now I do beta. So they tell me cosine beta is negative 5 over 13, and that beta is between pi and 3 pi over 2. So I draw a little coordinate system here, and I think about being between pi and 3 pi over 2. That's in the third quadrant. Okay, so again, I'm going to draw an angle. I don't know how big the angle is. Doesn't matter. And I'm going to label that beta. Now, here's where students sometimes run into trouble. It's the reference angle that we're using. So you have to go to the x-axis. If you don't draw your triangle right, you're not going to get the right functions. I mean, you're not going to get the right values for the functions. So be careful on that. The right angle has to be connected to that x-axis, okay? So, you can try other things, but I see students do that sometimes and they get kind of messed up. So just, draw it upside down. It's going to be okay. And then that would be my beta. Okay, now this is my picture for the beta triangle. Okay, now we know the cosine is negative 5 over 13. Now I'm in the third quadrant, so I have to be careful with the signs this time. Not everything's positive. Okay, so I can make that adjacent over hypotenuse. Okay, so my adjacent would be the negative 5, and the hypotenuse would be 13. The hypotenuse is always positive. Okay, now I said I'd show you the Pythagorean theorem on this one. So we're saying if I have a negative 5 and I square it plus some y squared, that's this side right here. I don't know what that is yet, but I'm going to figure it out. Equals 13 squared. 25 plus y squared equals 169. Y squared equals 144. And so you get y is equal to either positive or negative 12. Well, in this case, it's got to be negative, right? Because you're in the third quadrant. So negative 12. Now that I know all 3 sides of the triangle, I can do the same thing. I can write out all the trig functions. So sine beta, so this is going to be for beta, sine beta is going to be opposite over hypotenuse, so negative 12 over 13. And then cosine beta, they gave us that, but we can write it again, negative 5 over 13. And then tangent beta, tangent's going to be positive in the third quadrant. So it's going to be 12 over 5. Okay, now that we have that information, we can apply it to our different formulas. So we go back, and now on part A, sine alpha plus beta, that's going to be sine alpha cosine beta plus cosine alpha sine beta. I'm trying to squeeze this in here. Okay, but now we use our cheat sheet here over here that we have in orange and green. I know the sine of alpha is 3 over 5. I know the cosine of alpha is 4 over 5. I know the cosine of beta, where's that? Negative 5 over 13. And the sine of beta is negative 12 over 13. And I'll be adding these together. Now it's a bunch of fraction work. So I get negative 15 over 65. I'm not going to simplify that because I got to get a common denominator anyway. Plus a negative 48 over 65. Add those together and I get negative 63 over 65. And I'm going to leave it as a fraction just like that. It doesn't simplify. Okay, now for the cosine. Cosine alpha plus beta is cosine alpha cosine beta minus sine alpha sine beta. And then I can just go to my chart. So it's a little bit of work to draw the triangles and all that on the right-hand side here. But in the end, then you can just pop them in. Okay, so cosine alpha is 4/5. Now, I meant to put it in orange. 4 over 5. And then the sine alpha was 3 over 5. And then the cosine of beta was negative 5 over 13. And the sine of beta was negative 12 over 13. And this was subtraction. Okay, so I get negative 20 over 65 plus, right, it's going to be plus, 36 over 65. And that gets me 16 over 65. Now, that does not simplify. 2 does not go into 65, and 16 is just 2 to the 4th power. Okay, so those two are done. So now we'll go to tangent alpha plus beta. That's going to be tangent alpha plus tangent beta over 1 minus tangent alpha tangent beta. But we know these. I have to scroll up a little bit. There's my tangent. So tangent alpha is 3 over 4. So 3 over 4 here. And then I'm going to have a 3 over 4 here. Okay. And then what's my tangent beta? 12 over 5. Okay. So we'll put that in. 12 over 5. And this is going to be times 12 over 5. Then I'll put in the other stuff that I need, like an addition sign here, and a 1 and a minus. And you have a better way of writing it out, but that's fine. Okay, now I'm going to get a common denominator of 20 in the denominator. So I'm just going to go ahead and work with 20 as a denominator. So I'm going to have 15 plus 48 over 20 in the numerator. And then in the denominator, I'm going to have 20 minus 36 over 20. So you can think about that fraction work later in your spare time if you want. Whoops. Okay, sorry about that. The 20s cancel. So what do I get? 15 and 48 is 63 over 16. This whole thing's going to be negative though, right? Okay, so minus 63 over 16. So I think that looks good. And then we have to do tangent alpha minus beta. So tangent alpha minus tangent beta. So much more room to write. 1 plus tangent alpha tangent beta. Now, if you look, where does the difference come in? Well, the values were the same, right? It was just these two signs that are switching. So I can write 3 over 4 minus 12 over 5. And if you don't like thinking about it that way, you just go back and pull them off that chart. 1 plus 3 over 4 times 12 over 5. And then we do a little bit of work just like we did before. We're going to have 15 minus 48 over 20. And then we're going to have 20 plus 36 over 20. 20s cancel. So what do I get here? 15 minus 48 is what? Negative 33. And then in the denominator, I'm going to have 56. 33 is just 3 times 11, and 3 doesn't go into 56, and 11 doesn't go into 56. So I will say that one is done as well.